I see crimes.
Wait, okay, that's wonderful.
That really had the potential to be embarrassing. I might not have gotten it. All right. Okay. Hi, everyone. To remind you, tomorrow is the lab day. Office hours are Monday. I am generally on Thursday, not guaranteed to be in there like at any given time, except at 6 p.m. in UC 163, where we'll do the lab review session. So today we're going to basically finish up the global local overview, and we'll then take a broader view of what it's about. So tomorrow, you'll be doing exercises that are basically about that. And then depending on how far we get, we'll do what's called Boolean algebra. So things to look forward to. So, okay, so we did the first three. So we'll just do the rest. There's not very many left. So I believe actually we've done this one as well. So let's move on to this. So to remind people, okay, we'll get to this too. So to remind people, what we are trying to do here is just consistently apply the rules. So let me just remind you what the rules are. So this is so those are the rules. So we have local variables, so variables that exist while the function is running, and global variables, so variables that exist for the duration of the program. And the way we know if a variable is local is if it's just in the parameter list, or if it's declared as not declared as global and is defined inside the function. Anything else means that the variable is global. Okay, and the reason we need to worry about it is that sometimes we have both a global and a local variable by the same name, in fact, quite often. So, for example, here. So here we have grade equals 95. So that's the first thing that happens. So when this happens, the global grade is now 95. Now we're saying get adjusted grade. And here what happens is we're sending the value of grade, so 95, to here. So the local grade here is 95. And now here we're saying return grade -5. So what does that mean? So return, remember, means that this is what the function computes. We're not actually changing the value of any variable here. We're just saying this is what the function computes. So this means that this expression gets the value 90. We're not doing anything with that 90, but if we were to print the expression on line 6, that would be the 90. So the value of the expression is 90, but we don't store it and don't print it. So now over here, we're not inside the function. So that means that the only possible value here is grade. And of course, like all the values are 95 anyway for like both the local variable grade that doesn't exist anymore and the global variable grade that was 95, never changed to anything apart from 95. So that's still 95. Yeah. So it does. So the local variable exists while the function is running, right? So when I'm here, I'm saying get adjusted grade. So here, this grade is going to get sent to this grade. So if I say step in, I'm over here. So while I'm inside the function, so I'm about to be on line 2. If I query what grade is, I'm inside the function. Of course, like it's 95 outside the function, but because I never change it. But here inside the function, when I'm referring to grade, I mean this grade, the local grade. When I'm outside the function, it's gone. Not exactly. So it's not that it transformed. It's that while the function is running, there is a global variable grade and also a local variable by the same name. So maybe it would be better if we look at it in a Python tutor. So it looks like this. So when we're here, so you see like there is a global variable grade and there is also a local variable grade. So then we'll return. So the return doesn't change any values of any variables. But what happens is that the local variable that's the grade inside get adjusted grade is just gone once you return. So all that's left is the global variable grade, which happens to have the same value. Make sense? So But anyway, like here, if you know that return doesn't actually change the value of any variable unless you tell it to, well, all the values of all the grades are 95 anyhow. So the only thing that could be printed is 95. So how would you change it? That's the next example. So that it does something useful, it's this. So the only change here is that instead of just saying get adjusted grade, which has the value 90, here we're saying the global grade is equal to get adjusted grade of grade. So you look at this. What's going on? So again, same code, except this function returns 90. So the value of this is 90, and we're saying put 90 in the global variable grade. And then this prints 90. Make sense? Questions about this? So, okay, so yeah. Oh, yeah.
I don't understand why name is defined here when we don't see it anywhere else.
Yeah, that's that. So again, kind of so line 5, I promised to explain it later in the previous lecture. So for now, we're just using the using this line as like a separator between calls to functions and the definition of the functions. So to answer your question directly, underscore name underscore is a special built-in value in Python, which is either the name of the file in which the program is, or in case that you have a multi-file program. If that doesn't make sense, I'll explain it in a more orderly fashion later on when we do multi-file programs. But if you have a multi-file program and you specify that you want to run this file, then name is going to be equal to main. Otherwise, it's going to be named something else. But again, like that's for the future. So that the more and more direct answer to your question is it gets defined when it press Control E. Yeah. All right. Yeah. Well, yeah. So that's in fact the U. So the question was, what disappears is the grade, to be clear. So if I return something, it usually will not disappear because usually I'll use exactly this pattern, right? So usually I'll say compute whatever function of the grade is and then store the result somewhere. Does that make sense? So, and that was actually the next thing that I was going to start talking about, which is for now, we treated those examples as just kind of like practice examples where we figure out what the output is. But really secretly, this was about passing data to functions and from functions in different ways. So ordinarily, in like 99% of the situations, what you want to do is this pattern. So what you want is you want to pass information to the function using a parameter. So you're saying, I'm sending this value to the function. And then you're saying the function is computing this. So that's like the same pattern that you would see in math, where if you have like a square function, let me call it square. So outside the function, you would say whatever, like x is equal to 50. And then you would say x squared is like square of x. Right? So that's the normal way that you would do it. So the x gets, let's call it y, just so that it's not the same. It doesn't have to have the same name. So what you're saying is send this value to the function. The function is going to figure out what to do with it and then store it or maybe print it outside the function. So the information goes to the function via here, and it gets returned from the function via a return statement and gets stored or printed by using this value. So this value you could print it directly, or you could say, take this value and put it in a variable for later use. Okay, so that's the normal way of passing information to and from functions. So the other examples in a way are usually not what you want to do. So here, but sometimes yes. So here what we're doing is we're passing the information to and from the function by setting the value of the global variable grade, right? So the function knows what they want from it by looking up the value of the global variable. And then I print the value of the modified global variable, right? So that's a way of doing it. Just modify a global variable. The function needs to know which variable I intend for it to operate on, and then it'll do whatever it is that it's supposed to do. So here, what we're doing is kind of a mix, right? So we're passing the information by sending it here. So to the function, it goes like this. And then there is like not really information being passed from the function at all, except that it prints the value to the screen. So here, again, the same thing, but just this changed. So this one and this one are just exactly the same, except the name of the local variable is different. Here it's kind of a mix, right? So here we're passing the value using a parameter. However, we are passing information from the function by setting the value of the global variable. And here we are just like, it's probably a bug, right? So it doesn't do anything that's useful. But the way you would think about it is you would say, okay, like the way we're passing the information is here we're sending the value to the parameter, and here we're saying, well, the value of this is whatever is the value that's returned. So usually we say the return value of the function, and then we store it. So again, usually what you want to do is this. The reason I bring this up now, I think many of you will have heard, like if you've taken programming before, will have heard, like, do not use global variables as the usual advice. That's good advice usually. There are situations where, you know, the alternative to using global variables is using a mechanism that we won't have covered until like week 11 or week 12 in this course. So if you know about classes, stuff like that, so those would be instance variables. We just don't have them. So the alternative in lab 2 and in project 1 will be to use global variables, because like that's the thing that makes the most sense if you don't have instance variable syntax. The other reason is that even if you don't want to use global variables in Python, Python doesn't really give you much of a choice, right? So here, this is a global variable. It gets defined automatically. And if you don't know about global variables in Python, you will be using them anyhow, maybe by accident. And if you don't know what's going on, you'll have bugs that you just have no idea how to fix. So that's like another part of the reason that we're bringing this up now. If you haven't heard about global variables before, I was just making excuses, don't mind me. Okay. All right, so so questions about this, anyone? All right, so let's just quickly repeat, because like some people I think find this slightly difficult, so it makes sense to repeat it, even though this was in the slides with just like other variable names the other day. So the two situations where you will have problems with a conflict between the implication that the variable is local and the variable is global is something like this, where the right-hand side implies that grade must be global because you're using the variable grade before you've defined it inside the function. So the only way that it would make sense is if the grade were global, right? But the left-hand side here implies that grade is local because ordinarily, if you say grade equals blah inside the function, that means it's local. So this is just a syntax. So this is kind of not a syntax error in this case, but this would just be, well, grade must be global. So you're just using this as the global. So if you have something like this, you have a grade, you have grade that's a parameter. So a parameter must be a local variable. If you then say global grade, then that means that you mean for grade to be global. That's just a conflict. So that's an error. And now it would be a syntax error. Make sense? All right. And those are like the two situations where you get an error. Otherwise it's just fine. So like when you're studying for the midterm, just like those are the examples. So, okay. Okay. Makes sense kind of questions. Okay. So, here, so I want to show you the lab just kind of as a preview. So, we're going to finish up all the, so this might be, so you see, this is like from last year. So I might modify it like tonight or tomorrow morning before 12, but it's basically going to be this. And this is just kind of to give you an idea of what we're doing. So this is like the main thing. So we're doing like a calculator thing, right? So what that means is we have kind of in the pocket calculator, like this one. So I think people still use those. I don't know. So it's kind of like this. So you say like, 5 times 5, whatever, that's like 25. And then if you press like +3, so here on mine, it actually displays 25, but you have the current value and then you press equal and then the current value becomes 28, right? And then if you say like square root, actually it wants the square root here. Okay, not going to do the square root. I'm just, yeah, I'll do undo. Okay, 28. And then I do like times 6. And that would be this, right? So it kind of works like this. So on most calculators, you just have the current value, and then you say like plus whatever, and you get the next value. So what we're doing here is we are defining the current value. That will be the global variable. And then we have functions that basically simulate different buttons on the calculator, right? So add, for example, you say like add 5. So that would add 5 to the current value. And then you say like divide, and that would like divide the current value. So then you have, so this one doesn't actually have like memory and recall, but if you press memory, that means that later you can press recall, and that would bring up the current value from when you pressed memory. And then you'll have undo, which this one actually does have, which would roll back the current value to the previous current value. So the undo here actually like does like undo button by button. So yeah. Okay, so the reason it makes sense to do a global variable here is that the alternative is to pass around the current value as well as when you press memory and recall, the saved value, as well as like a bunch of other things when you get to undo. So, and that's like passing around a bunch of things, which makes the program actually less clear. So in this case, having global variables that keep track of the current value, the previous value, whatever you need, the value that's saved, it actually makes sense to use global variables. Okay. Does this make sense? So this is actually similar to the kind of add courses, drop courses example that we had done the previous day, right? Where like the current value was the current number of courses that you've taken. And then you had like add drop, which modified the number of courses that courses that you currently have. Yes. Yeah. Oh, yeah. Okay. Anyone else? Yeah, you seemed like you had a question. All right. Okay. So like, yeah, so read the handout. Should be so this is all like not like a super easy lab, but also like I think like not a super hard one, until you get to questions 8, 9. So the link is in the slides here, so you don't have to take a picture, but you can. So okay. So yeah. All right, so the one thing that you need to know for the lab, which I haven't talked about yet, is this idea of swapping the values of two variables. And that I want to do in Piezo. So swapping is just like the usual way that people say it. So the task is like this. We have like A is equal to 5, and we have like B is equal to 6. Okay, and we want A to have the old value of B, and B to have the old value of A. So one thing that you might be tempted to try for this is you might like to say A is equal to B, B is equal to A. But that's a bad idea. Why is it a bad idea? Anyone? Yeah.
That A, B, so then B will change.
Exactly. Yeah. So this would just make both of them be B. So here it's going to be like A is 6 and B is 6. And once you've done that, you've overwritten the value 5. There is no getting it back. So A is equal to B is not actually going to do anything. It's still going to be the case that A is 6 and B is also 6. All right, so what can you do? Well, it's kind of what I implied, right? So what you really don't want to do is you don't want to forget the value 5, even after you make it so that B gets assigned to A. So the usual thing that people do is they say temp. So I'll do like A is equal to 5, B is equal to 6. So we'll say temp is equal to A. So that makes it so that temp is 5. And now A is 6 and B is 6. So that's great. But now we haven't forgotten what the old value of A was, so that after we set temp is equal to A, it's fine to say A is equal to B. So temp is still the same, but A is now 5, but now A is going to be 6 and B is going to be 6. But we still know the value of old A, so that when we say B is equal to temp, we get to, so temp is still 5, that has not changed. A is equal to 6, that has not changed. And B is 5. So we successfully swapped the values of A and B by using this temporary variable. Yeah. So it's just like another variable. So temporary means that, so kind of temporary, the word, right, means that you're just like for a while storing the value somewhere else. So here we're just saying, we'll just define a new variable that'll store the old value of A. Right? So our problem here was that when we say A is equal to B, the old value of A just gets overwritten. So we don't know it. So the way we solve it is we say, well, we'll store the initial value of A in the variable temp. So now there is no problem with overwriting the old value of A because we've saved it. Make sense? So, all right. So that is one way to do it. So another way to do it is a trick in Python. So again, assignment means we are assigning the value of the right-hand side to the left-hand side. In Python, you can do something like this. So you can say A comma B is equal to 5 equals 6. And that makes it so that the right-hand side values that are separated by commas get assigned to A and B simultaneously. So in order to swap A and B, what you can do is A comma B equals B comma A. And unlike lines 12, 13, this is actually fine. So this makes it so that B goes to A and A goes to B. Okay, and that's the usual way that you do it in Python if you need to. So that's Python specific. So when you do C in ESC190, you'll have to do swapping kind of the normal way. Okay, yeah. Sorry, I'm having trouble hearing you. Oh yeah. So I kind of used it. So the question was about kind of this versus this. So you know, in a way, a comment is just like I can write whatever I want there. So it's more like why did they choose to write it like that? And the reason I chose to write it like that is that in Python, a single equal sign means take A and put it into temp, whereas this means that kind of the assertion that this is true, that temp is actually equal to temp. So this is like true. This is that way in Python. Of course, in the comment, I could have written a single equal sign as well. I just chose to kind of, well, whether that makes it less confusing or more confusing is a matter of taste, but I was going for less confusing. Yeah.
Like what B was.
Why B was, yeah, what about it? Oh, I see. Okay. Okay. That's definitely more confusing. Sorry. The reason is typo. Yeah. Thank you. Okay. Yeah. Good question. Yeah.
But if we were dealing with three variables like A, B, and C, could we make multiple?
Yeah. So this works for any. So like as long as the number of variables on the left is the same as number of variables on the right. Yeah. All right. Or like values on the right. So okay. So that's like that. So throughout this course, I'm going to sometimes give kind of problem solving questions kind of just for fun. So those questions, like everyone kind of knows, well, like everyone in the field kind of knows the answer, but like you have to think about it the first time you do it. So part of why everyone knows the answer is that there is like a set of like, I don't know, like probably like a couple hundred questions that people like often ask at job interviews. This is like one of them. It's like a slightly silly practice because like if you see the thing for the first time, it's kind of difficult and you just got to study. There is a book, well, multiple books with all of the puzzles that you're kind of supposed to memorize before you go and interview for a fancy job. Yeah, so it's like there's like the other reason that people ask them is like because they're kind of fun. So we're gonna go with that. So I'll give you a hint about what you do first, and you can try to solve it. So the first step, well, one of the first possible steps is to do this. All right, and I'll tell. Well, like this is certainly something you can just Google or ChatGPT or whatever, but I'll also tell you next week. Okay. All right. So I will move on to the next thing. We already kind of spoke about Boolean values, so true and false. I promised you a picture of George Boole. This is George Boole, after whom Boolean values are named. You can read more about him on Wikipedia. So Fun Toronto. So he's English, but Fun Toronto Connection. He's like the great grandfather maybe of Jeff Hinton, who is here. Yeah. who won the Nobel Physics Prize for neural networks last year. Okay. So I'm not sure who's more famous at this point, but anyways. We have those kinds of operations that you can have on Boolean values. So this is kind of like algebra, and you'll see a connection later on in the slides as well. So the way it works is you can say something like true, and that would be true. You can say something like true and false, and that would be false, for example. So the way it works is X and Y is true only if both X and Y are true. On the other hand, X or Y is true if at least one of X or Y is true. Otherwise, it's going to be false. So that means that the only way that you'll have like X or Y be false is false or false. And the only way that you could have X and Y be true is if X is true and Y is true. So let's do a little example. So if I say like X is true and Y is false, and then I say X and Y, print it. That is false. And the reason this is false is because the only way that X and Y is true is if both X and Y are true. So this would print true. Yeah. Yeah, in a second. Like actually lots. Yeah. Let's do an application. So you might, for example, say, okay, I want to okay. So this is like high school standards. So like, let's say that we want to do this. So one way that you could do this is you could say, okay, so let's say that your grade is 87, and you say if the grade is smaller than 80 or the grade is greater than 90, we'll print not me. Otherwise, you can print me. Okay, so that's an example. So basically what we're doing here is we're saying, okay, like if one of those is true, then it's, something remarkable. Otherwise, we print me. So you can also do it with an and. So you can say if grade is greater or equal than 80 and grade is smaller or equal than 90, then it's like this. Otherwise, it's like this. So those happen to be equivalent. Make sense? So like anytime, so especially in the beginning, kind of the application is going to be kind of conditions here, right? So if you have a condition that's kind of complicated, so like it happens that you can write it with, like grades smaller equal than 80, smaller equal than grade smaller equal than 90 as well. But here, like this kind of thing, if you're thinking, well, like if it's smaller than 80 or if it's greater than 90, I just want to do this, then that's how you do it. Make sense? Okay. So let's go back to kind of the table. No. So again, kind of when we are writing a condition, and we'll have more examples later on as well. So if we want to combine two conditions, and the way we want to do it is that it should only be true if both are true, then it's going to be like this. If we want either one is true or both are true, then we do an or. Another thing that you can do is not. So not true is false and not false is true. is the basic idea. So that means that if you have something like this, and then you have not x, that's going to be like this. You can do it with parentheses, but you can also do it like this. So x is true, so that means that not x is false. Make sense? So, and you can like combine those, right? So you can say, so you can like invert this. So I'll copy this guy. And I'll say, if not both of those things, then I'll print not me. And otherwise I'll print me. And that's, again, equivalent. Right? So I'm saying if it's not the case that grade is both greater or equal than 80 and grade is smaller or equal than 90, then I print not me, otherwise me. So you can kind of see logically that that's the same. All right. So we kind of, so we kind of started doing the example because I was asked about the application, but let's start with kind of easier examples. So what's a Boolean value? So you could explicitly say something like x equals true, and then x is true. But you could also say something like x is equal to 7 is smaller than 5. So the value, like we saw in probably the first lecture, the value of 7 smaller than 5 is false. So once you execute it, what's going to happen is the value of x is going to be false. Make sense? And you can combine those. So whether that has applications or not, that not really clear, but you can say like not 7 smaller than 5. So now x is going to be true. Because this guy is false, and then not 7 smaller than 5 means only be true if 7 is greater or equal than 5, and it's not. Well, it is, sorry. So that means that this whole thing is true. Because it's not the case that 7 is smaller than 5. So it's true to say that 7 is smaller than 5. Does that make sense? Questions? All right. So that's like that. So let's do kind of so let's do kind of a compound thing. So you can say like not 7 smaller than 5. And 6 is equal to 7 or something. What's the value of this? Anyone? Yeah, it's false. So why is it false? Because this is true and this is false. And then if you have true and false, well, they're not both true, so the whole thing is false. Does that make sense? So this is false. And the way you do it is you could just like do the math, right? So you literally say, okay, so this is equal to not false and false, and that equals to true and false, and that equals to false. Or you can just logic it out and say, well, like 70, so not the case that 70 is smaller than 6, that is true. And it's not the case that 6 is equal to 7. And what we're saying is like only be true if both are true. And it's not the case that both are true. So, okay. So one thing to note here is that there is like not an exact correspondence between or in Python and or in English. So in Python, the technical term for the or is what's called inclusive or. So in order for X or Y to be true, it needs to be the case that either X is true or Y is true or both are true. In English, that's at least not always what is meant. So if you hear me say, I will have pie or ice cream for dessert, you probably understand me to mean that I will have one or the other, but probably not both, right? Because if I meant both, I would say I will have pie and ice cream, right? So in English, at least sometimes, most of the time probably, when you hear or, what is meant is something different. It's the exclusive or rather than the inclusive or. So be careful when you write that. With that said, so let's actually do this example. It's kind of fun, but it also, I think, makes an interesting point. So it's going to be similar to what we've done here in a way. So I'll have like, we'll have pie as true, and we'll have ice cream, I'll write IC as, let's say, false. And then I want to print I lied if I will have pie or ice cream is true in English. Sorry, it's not true. And I did not lie otherwise. So what we said is this would not work. So it would not work to say if we'll have pie or we'll have ice cream. So this would not work in terms of making it correspond to English because it will print I did not lie if both are true. Does that make sense? So let's say that I want to do this. So how to do this? Anyone has ideas? Yeah.
Both of them are.
Yeah. So work out the situations where I did not lie, and then just print that I did not lie, right? So what are the situations? The situations are if pie and ice cream. Oops. Sorry, or the other way. I'll post notes if you don't want to copy. Hopefully tonight or tomorrow morning. So kind of the more important thing is to get the idea. Right. So I just kind of listed the two situations where I did not lie. So I did not lie if this is true and this is false, or if it's the case that this is false and this is true. Right. That's what it means in English. It's like one of them is true, one of them is false. Right. So that was your idea, and that works. So there's other ways of writing this, but there is like actually like a very short way of writing this, which is if we'll have pie is not equal to we'll have ice cream, then I did not lie. And else I'll print I lied. And that does it, right? Because like, when is it true that I did not lie? When one is different than the other. So that's like one of the reasons people sometimes ask, like, how do you do exclusive OR in Python? And the answer is, well, you can just say not equal. That's equivalent to exclusive OR. Questions? So, okay. So, a few quick notes about why this is kind of like algebra. So in arithmetic, you have so in programming languages, it's called operator precedence. In mathematics, sometimes as well. So like you know that like 1 + 2 × 3 is equal to 1 + 6, and not like 1 + 2 all of that times 3. So that means you do the times's before you do the pluses. So in the same way, in Python, you do the ends before you do the ORs. And you do the nots before both. Okay, so that's like a way of doing the order of operations. Here is kind of an example of where it's important. So if you have something like this, so if you don't know, growth mindset is the idea that you can, grow and learn. It's not about like innate talent, it's about, grit. You can have something like this, and what will it print? Well, so let's say you have like not lazy, smart, and no growth mind, and not growth mindset. That's like not you, it's someone, right? So go to anxi as if it's like not lazy. So not lazy is true, and smart, this is true, and growth mindset, this is false. So it doesn't matter what order you do the ends, it's not anxi. So lazy and smart, so that's like false and true. So that's false, so not physics either. So you compute not lazy first, that's true, and smart, that's true, not growth mindset, that's true. So it'll print go to economics. Okay. You can try it, it will. Again, like all of those, well, 2 of those majors exist at TMU actually, so you can do both. Anyway, all right, I will see you tomorrow. Bye.
Not lazy, that means that lazy is false. So if it's not lazy, then
So the not lazy is true. Yeah. Yeah. See ya.